answering to the sample question number C. Question number 5. Look here. The atomic number of an element is 22. Question is, write the subshell electronic configuration of the given element. Which group does it belong? So, atomic number 22. Write the subshell electron configuration. See here, answer 1s2, 2s2, 2p6, 3s2, 3p6. After 3p6, write 3d. Don't put the electrons for 3d. 4s2. After filling 4s, remaining electron is put into D subshell. It is look here. 4, 10, 12, 18, 20. Remaining electron is 22. Otherwise, we can write in this form also. Argon 18, 3d2, 4s2. This is the shorter method of writing the electron configuration. Which group does it belong to? Since the last electron is filled in D subshell, it belongs to D block elements. It is the D block element. To find the group of D block elements, add the electrons of S subshell and this D subshell, 4s and 3D subshells electron you have to add to find the group of D block elements. Since it has 4s2 and 3d2, the group of this element is fourth group element. Once again look, to write the configuration, 1s2, 22 is the atomic number, 1s2, 2s2, 2p6, 3s2, 3p6, next 4s2, after remaining electron is put into the 3d subshell. Otherwise, in the shorter way, we can write argon 18, 3d2, 4s2. To find the block or to find the group, since the last electron fills in a D subshell, it belongs to D block elements. To find the group of the D block elements, add the electrons of 4s and 3d. Since the 4s is 2 electron and 3d also 2 electron, the group of this element is 4. Next question number 6, look. The volume of fixed mass of gas at P1 atmosphere pressure is 10 liter. Question A. What will be its volume if the pressure increased to 5 atmosphere? State the gas law applicable here. Question. The volume of a fixed mass of a gas at 1 atmosphere pressure is 10 liter. So we can write 1 atmosphere pressure, that is P1, it is equal to 1 atmosphere pressure, volume 10 liter, volume V1 10 liter. What question here there? What will be the volume if the pressure is increased to 5 atmosphere? That is, when the pressure P2 is 2 atmosphere, what is volume? V2 is equal to how much? Apply the Boyle's law. P1 V1. Boyle's law. P1 V1 is equal to P2 V2. That is P1 1 into V1 10 equal to P2 5 into V2. 5 atmosphere. That is V2 is equal to 10 by 5, that is 2 liter. It is the answer. See question. What will be its volume if the pressure is increased to 5 atmosphere? P1 you write 1 atmosphere, V1 is given 10 liter, P2 is 5 atmosphere, and what is V2? Formula C, Boyle's law apply here, P1 V1 is equal to P2 V2, 1 into 10 is equal to 5 into V2. Therefore, V2 is equal to 2 liter. State the gas law applicable here. Here you have tried Boyle's law. So question number B, Boyle's law. Boyle's law. At constant temperature, the volume of a fixed mass of a gas is inversely proportional to its pressure. At constant temperature, the volume of a fixed mass of a gas is inversely proportional to its pressure, or V is inversely proportional to its pressure. V is inversely proportional to pressure. This is Boyle's law. Next question, question number 7. In a galvanic cell, zinc rod is dipped in zinc sulfate solution and silver rod is dipped in silver nitrate solution. Question A. Identify the electrodes. Identify the electrodes at which oxidation takes place. Oxidation takes place always in more reactive metal. Among zinc and silver, zinc is more reactive, so zinc loses electron. Therefore, the answer is identify the electrode at which oxidation is taking place is zinc. Remember always the oxidation is taking place in more reactive metal. Here in this case more reactive metal is zinc and silver is less reactive metal, so oxidation is taking place is zinc. Question B. What is the energy change taking place in the galvanic cell? The energy taking place in the galvanic cell is chemical energy into electric energy. Chemical energy to electrical energy. The energy taking place in galvanic cell is chemical energy to electric energy. Question B. What is the energy change taking place in electrolytic cell? In electrolytic cell, electrical energy is changed into chemical energy. Electrical energy is changed into chemical energy. So in electrolytic cell, electrical energy is changed into chemical energy. In galvanic cell, chemical energy is changed into electrical energy. B. In which electrode oxidation takes place in electrolytic cell? Question B. That is in anode. Anode, positive electrode. Positive electrodes. Anode, or we can write positive electrodes. Anode or positive electrode. Eighth question. A homologous series is given. See here CH4, C2H6, C3H8, blank A, C5H12, again blank B. The question is find A and B. Question number A, find A and B. Question is like this, find A and B. Look here is the series here, CH4, C2H6, C3H8. You can see a difference of CH2, that is from CH4 to C2H, there is a difference of CH2. From here to here also there is a difference of CH2. So there must be a difference of CH2 to here also. So we can write A is C4H10, C4H10. Again C5H12, it is correct. Again there is a CH2 difference, so we can write B is C6H14, double plus 2. If carbon is 5, hydrogen is 12. That is carbons double plus 2. C3H8, double plus 2. So we can write The general formula. What is the general formula? Here, the question is, what is the general formula of the given homologous series? Cn H2n plus 2. It is the general formula. That is, when carbon is 1, hydrogen is 4, double plus 2. Carbon is 2, hydrogen is 6. Carbon is 3, hydrogen is 8. So there is a difference of CH2. Such series we can call it as homologous series. Next question, ninth question. Ninth question. What is meant by polymerization? Write the name of the monomer of polythene. Question A there also. What is meant by polymerization? Polymerization is a process of simple molecules joined together to form complex molecules. Polymerization is simple molecules joined together to form complex molecules. Simple molecule joined together to form complex molecule. It is polymerization. To form, very simple, easy to remember, simple molecules joined together to form complex molecule is polymerization. Complex molecule. Question B. What is the name of the monomer of polythene? What is the name of monomer of polythene? That is, answer is ethene. Ethene, when polymerizes, give polyethene or polythene. When ethene polymerizes, it gives polyethene, or we can say polythene simply. So, question B here. So, question A, what is meant by polymerization? Write the name of the monomer of polythene. Simple molecules join together to form complex molecule. This is the polymerization. And when ethene polymerizes, we are getting polyethene. So ethene is the monomer. Question B. What are the two types of polymerization? That is addition polymerization and condensation polymerization. The answer is addition polymerization. Addition polymerization and question B. What are the two types of polymerization? The answer is addition polymers and condensation polymers. Addition polymers or addition polymerization and condensation polymerization. Addition, condensation polymers. Addition polymers and condensation polymers. So these are the two types of polymerization. One is addition polymers and condensation polymers. Question B. What is the polymer of vinyl chloride? Vinyl chloride polymerizes to give polyvinyl chloride or PVC. When vinyl chloride polymerizes, we would get polyvinyl chloride or PVC, a important plastic. See, the monomer of PVC is vinyl chloride. We can write vinyl chloride is like this: CH2 double bond CH, Cl, N times. When it polymerizes, we are getting CH2, CH, Cl. So this is PVC, polyvinyl chlorides. So there are the two types of polymers, addition polymers and condensation polymers. When vinyl chloride polymerizes, we will get polyvinyl chlorides. Next question. Which method of concentration is used in each of the following situations? Which method of concentration is used in each of the following situations? 1. The density of the ore is more than that of the gangue. When the density of the ore is more than that of the gang will be removed by hydraulic washing or washing with water. The answer is hydraulic washing or washing with water. So 10th question, which method of concentration is used in each of the following? The one question 1, the density of the ore is more than that of the gang. The answer is hydraulic washing or washing with the water. When the density of ore is more than the gang, it can be removed by, the gang can be removed by washing with water or hydraulic washing. That is the answer, hydraulic washing. And question B, the density of the ore is less than that of the gang. The density of the ore is less than that of the gang. It can be removed, the gang can be removed by froth flotation process. The answer is froth flotation process. Froth flotation process. Usually, sulfide ores are concentrated by this method, froth flotation process. The density of the ore is less than that of the gang. So, this concentrated by froth flotation process. Usually, the sulfides ores are concentrated by this method. Question, X is a basic salt. Analyze the data regarding the acids and base from which X is formed. So here, question is, X is a basic salt. The analyze the data regarding the acid and base from which X is formed. Question 1. The acid is formed when carbon dioxide is dissolved in water under pressure. Question is, when carbon dioxide is dissolved in water, the name of the acid formed is carbonic acid, H2CO3, carbonic acid. When carbon dioxide is dissolved in water, we are getting carbonic acid, H2CO3. Question 2. The base is formed by chloroalkali process is sodium hydroxide, NaOH. NaOH, the base is formed NaOH. Identify the salt X and write its chemical formula. Third question. Identify the salt X. The salt is Na2CO3. When sodium hydroxide reacts with any acid, we are getting sodium carbonate. So sodium hydroxide dissolved in H2SO3, we can get sodium carbonate. The acid is carbonic acid, the base is sodium hydroxide, the salt is Na2CO3. So the equation, they asked you to write the equation, write the chemical equation of the hydrolysis of the salt. So we can write Na2CO3 plus H2O gives Na2CO3 plus H2O gives NaOH plus H2CO3, carbonic acid. Not balanced. 2NaOH3. Okay, now it is balanced. So, starting from carbon monoxide, how methanol and ethanoic acid can be prepared. When carbon monoxide treated with hydrogen in the presence of a catalyst under 573 Kelvin, we are getting methanol. CO plus 2H2 gives CH3OH. When methanol is treated with carbon monoxide in presence of catalyst, we are getting ethanoic acid. Ethanoic acid. Okay. Next, question number 13. Question A and B options are there. Question A. There are 6 carbon atoms in a saturated hydrocarbon. There is a methyl group at the second carbon atom. Question A. Write the structural formula of the given hydrocarbon. Question B. Write the structural formula of any possible chain isomer of it and its IUPAC name. The question is, there are 6 carbon atoms in a saturated hydrocarbon. There is a methyl group at the second carbon atom. So, including the methyl group, there is 6 carbon atom. So, we can write the chain only 5 carbon atom. Look here, answer is question A, 5 carbon atom, right? 1, 2, 3, 4, 5. Number it's 1, 2, 3, 4, 5. Second carbon, they said, right? The second carbon, there is a methyl group. So we can write here a methyl group, CH3 here. Now for the hydrogen atom, here CH3, here 3 is gone, only 1 hydrogen. Here CH2, here CH2, here CH3. So total carbon 6, hydrogen 3, 6, 7, 9, 11, 14. So we can write such the name of this compound is 2-methyl 2-methyl pentane. 2-methyl pentane. Molecular formula molecular formula is C5 C5 3 1 2 3 4 5 6 C6 H14. So the question number B, write the structural formula for any possible chain isomer of it and its IUPAC name. Question B we can write answer 1, 2, 3, 4. We can write here. Put here one CH3, here also one CH3. Now there are 6 carbon atom and number it 1, 2, 3, 4. And name of this here hydrogen 3, here hydrogen 1, here also 1, and here also here 3. So hydrogen total 6. Sorry, carbon 6, hydrogen look here 3, 4, 7, 8, 11, 14. Okay, now structural formula is same. So we name these compounds 2, 3 dimethyl butane. Dimethyl butane. Molecular formula is C6H14. Another compound we can write. So here again write bu 1. This here CH3, here CH3, here CH2, here CH3. Look, carbon 6, hydrogen 3, 6, 9, 11, 14. Okay, C6H14 molecular formula, C6H14, and name of this compound is 2, 2 dimethyl butane. 2, 2 dimethyl butane. So these are the two chain isomer of 2-methyl pentane. So the difference in chain, molecular formula is same, but there is difference in chain. So we can call it as chain isomers of 2-methyl pentane. This is the 2-methyl pentane. This is the 2, 3 dimethyl butane, and this is the 2, 2 dimethyl. Question B. There are 5 carbon atoms in a hydrocarbon. There is a double bond between the first and second carbon atom. Question A in that. Write the structural formula of its isomer. Question B. Write the structural formula of another unsaturated hydrocarbon having molecular formula C5H8 and its position isomer. Question look here. There are 5 carbon atoms in hydrocarbon. There is a double bond between the first and second carbon atom. Since there is double bond, these compounds are called alkenes and 5 are carbon atom. Let us write 5 carbon atoms. There must be a double bond. 1, 2, 3, 4, 5. Let me give a double bond here. So we can write hydrogen atoms here, 2 hydrogen, then 2 gone, 2 hydrogen here, and here only 1 hydrogen, here 2, here 2, and here 3. So number it 1, 2, 3, 4, 5. So we can write pent 1E. Name of this compound is linase. We can change the position of the double bond. For second carbon atom, give the double bond. We can write C 5 carbon. Give the double bond here, and we can put here CH3, here CH, here CH, and here CH2, here CH3. So the name of this compound is 3, 4, 5. Second carbon atom, so we can write pent 2E. Molecular formula look here, C5 must be H2N, C5, 2, 3, 5, 7, 10. So C5, H10, double. Molecular formula. And here also molecular formula C5 H3 4 5 7 10 C5 H10 double hydrogen alkenes carbons double there is hydrogen atom. And in another question there they gave write the structural formula of another unsaturated compound hydrocarbon having molecular formula C5H8 and its position isomer. Since the molecular formula C5H8, it must be alkynes. In alkenes, C5H10 means it is double, and in alkynes, it is C5H8 it is given. So we can write here answer. Question B. Write the structural formula of another unsaturated hydrocarbon having molecular formula C5H8. Write the C5. 1, 2, 3, 4, 5. Give a, since it is alkyne, there must be a triple bond. So give the triple bond here. Here, 1 hydrogen for this. And here no hydrogen for this H2. Here also H2 and here H3. So total C5 are 1, 2, 4, 1, 3, 3, 5, 8. So C5H8. C5H8. Another isomer of this you can write. Change the position of triple bonds. Writing the chain. 5 carbon atoms. Change the position of triple bond. You give the triple bond here. So this 3 hydrogen. There is no hydrogen for this. No hydrogen for this. Here 2. Here 3. So here C5H8. C5H8. So okay, this is the answer. molecular formula. So these are isomers. Since position of bond is changed here. So there, here first carbon and here second carbon.